All right, this is chapter 3, section 1, identify pairs of lines and angles. Okay, so the first two definitions that we have are for parallel and skew lines. So parallel lines are coplanar lines that do not intersect. So they lie on the same plane and they do not intersect. There's two examples down below. We've got two lines where it looks like if they go on forever, they're still never going to intersect. And the notation for saying that they are parallel is down here. We just put two small arrows somewhere on the lines that's not at the ends, okay? And pointing in the same direction. So if you were to draw two lines and you wanted to signify that they are parallel, you just put a little arrow in the middle of them, pointing in the same direction, okay? Skew lines are non-coplanar lines that are neither parallel nor intersecting. Okay, so skew lines cannot be parallel. Okay, they cannot be parallel. So for example, if we take a look at this image, so we've got this line, this horizontal line, which is on our plane. And then we've got another line that is passing through our plane. So it intersects the plane here, so not at our line, so it doesn't intersect. And then remember, it's a dotted line behind the plane, and then it continues out further down here. So it never intersects. It's one way to think of skew lines is both lines are on separate planes. Okay? So they will never intersect, but they are not parallel. All right? Okay. Planes that do not intersect. So let's give an example of two planes that don't intersect. Well, let's take plane A, B, G. Plane ABG. That is this plane right here. Okay? Now, it intersects all of the other planes except for one, and the other plane that it doesn't intersect is this one down here. Okay? So, plane CEF will not intersect. Okay, another set of planes that will not intersect are plane BHC, that's this one right here, and AGD. Oops, not H. AGD. All right. So we've got two sets of planes that will not intersect. There's more, but those are just two examples. Okay. Postulates. So parallel postulate. If there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. Okay. So for this postulate, I want us to go ahead and draw a line. And it says there's a line and then there's a point not on the line. So just draw a point outside the line, okay? There's exactly one line through the point parallel to the given line. So if we draw a line through this point and parallel to the original line, this is our only solution. Only possible line. Okay, there's only one possible line that can go through that point and also be parallel to this line. Okay. Perpendicular postulate. If there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So let's go ahead and start with a line. and we're going to start with a point outside of this line, okay? Now, what the perpendicular postulate says is there is only one line that exists that will make this angle between the two lines 90 degrees. Okay? There's only one possible line. Any of the other lines that you could think of would form an angle, but it would not be a 90-degree angle. There's only one solution there. Okay? It's two. All right, transversals. So a transversal is a line that intersects two or more coplanar lines in different points, okay? So our transversal here, let's go ahead and highlight two or more coplanar lines in different points. And this would be line M, okay? Because it has 1, 2 intersections. That is our transversal, okay? All right, and now J and K are the other two lines, but see how they only intersect the transversal one time? The transversal intersects both of the other lines twice, okay? So our interior angles. So for the interior angles, I want us to highlight this little box right here. That's actually, hold on, thick. Let me erase that. Okay, so there's a little area right here. So this is box. We're just gonna highlight this box, okay? So all of the angles inside the red box, inside red box, are considered interior angles. So that would be angle 3, angle 4, angle 5, and angle 6. The exterior angles lie outside the red box. Okay, that would be angle 1, angle 2, angle 7, and angle 8. Okay? So remember, the interior angles are the ones inside that red box, and the exterior angles are the ones outside the red box, okay? Just to make sure that we've got this down, I want us to draw another set of transversals, so it can also be horizontal. Just draw an angle here, or a line here, another line here, and a line that goes through them, okay? So we'll label this line J, line K, line M. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8. Our red box would go around the same angles. So 3, 5, 6, and 4. Okay? So our interior angles for this case are 3, 4, 5, and 6, and our exterior angles are 7, 8, 1, and 2. Alternate interior angles. Those are two non-adjacent interior angles on opposite sides of the transversal. So if we were to look at our interior angles in the figure, let's go ahead and highlight those in our red box. That would be these. Alternate interior means that let's take 3. Oops. Let's use the pen. Circle 3. Alternate means we flip over the transversal, which is M. So we're going to be on this side, on the right side, and then it's on the opposite side. So alternate interior would be 6. So angles 3 and angle 6 are alternate interior, and the other pair would be 4 and 5. Okay. Now, alternate exterior angles. So these are going to be outside of our box. So it's going to be 1, 2, 7, and 8. And 1 across the transversal would be 8. So angles 1 and angle 8, and then equal to across the transversal because it's alternating, and exterior would be angle 7. So angle 2 and angle 7. Same side interior or consecutive interior, that's where they're inside, they're an interior angle, but they are also on the same side. So let's take the interior, let's take the angle 3, same side would be 5, so angle 3 and angle 5. And then let's do the same thing for 4, that would be angle 6. And then corresponding angles. Corresponding angles is a little bit different. So what you're going to look at for corresponding angles is this box right here and this box right here. Okay? So for corresponding angles, each angle corresponds directly to another angle. So let's take 2 for example. 2 is in the top right of that square, so 6 would be the corresponding angle. So angle 2 and angle 6 are corresponding. Let's take a look at 3. Bottom left would be 7. So 3 and 7 are corresponding angles. Alright, let's take a look at 1. Top left would be angle 5. So angle 1 and angle 5. And then lastly, let's take a look at 4. That corresponds to 8. So angle 4 and angle 8. Okay? Take a look at our last slide. J and K clearly are not parallel, and M is their transversal. So, alright, now I've got some examples. So classify as true or false. A transversal intersects only parallel lines. These would be a no, or a false. And if you wanted to draw an image, you could draw a transversal, and then 2 lines that are not parallel. Skew lines are not coplanar. That is true. That's part of the definition. Okay? If lines are on the same plane or coplanar and they don't intersect, they are parallel. Skew is that they don't intersect, but they are not on the same plane. Okay? If two lines are coplanar, then they are parallel. That is false. Here's an example of 2 lines that are on the same plane but are not parallel. They intersect, okay? If 2 lines are parallel, then exactly one plane contains them. This is true. All parallel lines are coplanar. Okay? Think of each segment in the figure as part of a line. Which line or lines appear to fit the description? So let's try A. It says lines parallel to CD and containing point A. Okay, so let's look at A. A is right here. There's only one line that is exactly parallel, and that's line AB. AB is the only line that is parallel and contains point A to CD. Let's check B. Lines skew to CD. So skew means that they are not parallel, so it can't be AB, and it will never intersect CD. Well, AD will not work because that intersects D. AH will work. That's this line right here. That'll work. AH, because as we can see, it'll never intersect CD. And then there's one more, and that would be AG. All right, lines perpendicular to CD and containing point A. There's only one, and that would be AD. Why? Because of this 90-degree mark right there. And D, a plane that is parallel to plane EFG. All right, well, let's find EFG. That's this plane down here. Yellow is a bad color. Let's use green. Okay. And the plane parallel would be this one up here. And it contains A, so it's A, B, C, D. Plane A, B, C, D. All right, name the given angles. So alternate interior angles. We've got two of them. Look at our interior angles, 2, 6, 3, and 7. How do we know that they're interior? Well, they lie inside the two lines that are not the transversal. And if we were to draw our red box, it would be right here. So alternate interior angles. One would be 2, the other would be 7. And then the other set would be 6 and 3. Angle 6 and angle 3. Corresponding angles, okay? Corresponding angles would be 1 and 3. Angles 2 and 4. Angles 5 and 7. And angles 6 and 8. And then alternate exterior. So that would be 1 and 8. And angle 5 and 4. Here's your homework. Good luck.